Hello, good morning everyone, or good afternoon, good evening, whatever time that you are watching this video at. This video, I'm Prathamesh Hazare, and this video we are going to talk about Apache Spark or PySpark, whatever you want to call it. Like in this context, it is going to be the same thing. And what we will be talking about is what actually is Apache Spark or PySpark, and when do we need to use it, and what is the architecture and how does it work, kind of. And so let's get started with the video. Well, before starting the video, you need to have some kind of prerequisite knowledge about Python and some famous libraries about in Python, such as Pandas. Like, I'm gonna explain you PySpark in context to Pandas first, because that will make it way simpler. So I would really advise, if you don't know Pandas, I would advise you to go and learn about Pandas and all that stuff, because it will make it a lot easier for you to learn PySpark. Well, this is in my case because I learned Pandas and then I learned PySpark, so it got me, well, gave me an edge in learning PySpark. You can start with PySpark as well, but then this video wouldn't be that useful for you. What Pandas does exactly is it extracts data and then creates data frame. Then it performs different kind of transformations like handling null values or handling absent values and all that stuff. Then it can be used to save data to MySQL or SQL database, or a kind of any kind of database, and then we can also create CSV files of the transformed data. This is Pandas. But tell me what will happen if I give Pandas, let's say, petabytes of data to handle. I will give you 2 seconds. One, two. You could have paused and thought about it. Well, what Pandas does is it does all of this processing on a single machine. Like if I am using my Jupyter notebook and doing Pandas operations and transformations, then it is gonna use my system's memory, my computer's memory or RAM or whatever you want to call it, to execute whatever the transformations are. What happens when the transformations and the data kind of exceeds the capacity of your RAM? Well, this will happen. Uh, because the Pandas library uses the local machine, the scope of transformations and using kind of different kind of stuff on data, doing different kind of stuff on data, the scope is, because the scope gets limited, because we can only handle a certain amount of data. Well, here comes PySpark. PySpark is nothing but Python plus Apache Spark. PySpark is basically the API which allows us to use Apache Spark and its architecture and its, well, technology in a Python script, using a Python script. And what Apache Spark does different is it uses a distributed computing architecture. What does that mean? Well, if I have a single computer, then I have to perform all those operations on that certain single computer, and I am limited by the resources on that single computer. But if I have, let's say, 20 computers and one extra computer, just to make it even odd, but you will understand. So that one computer will have my code of the PySpark, and what it will do is it is handling a huge amount of data. So what it will do is it will create 20 clusters in those 20 different computers which are left, and the code which I have on my main computer will generate different jobs or tasks for those different computers. Those different computers are called as clusters or executors or worker nodes, whatever you want to call it. We will call them worker nodes for now, or executors for now. In those executors, it will give different tasks, and what those different executors will do, it will return us the status of the task and the output of the task. What does that mean? Well, it means status means failure or success of the task, and output of the task. Like if we gave computer 1 or executor 1 the task to handle the null values in first 30 rows, then it will do that. It will return us success or failure, and it will return us the first 30 rows without the null values. You get my point? Yeah. So when do we actually need PySpark? Well, of course, I told you when the data in your is too big for a machine, then we need speed. Then we can use PySpark. Then if we are working in real-time data, like what is real-time data or what is streaming data is basically imagine an API or not an API, an app or a website which is continuously generating data of customers, and that data is continuously getting extracted by a certain, let's say, machine, and that data is continuously getting transformed into a useful form, and that data is continuously getting loaded into a analytical form so that the business people basically can draw some conclusions from it. That is called as streaming data. Then many companies actually already use PySpark or Spark, so it has become an industry standard. So it is kind of almost compulsory to learn nowadays if you are a data engineer. Yeah. Next is the PySpark or Apache Spark architecture. Well, you can see a lot of things over here. Well, this is a very boiled down architecture of Apache Spark, but it is still good enough to understand. Well, what we can see here is a master node, driver program, worker node, cluster manager, and all of that stuff. Well, let's start with master node. Master node is, let's recall that example which I told you, 21 computers, like one is main computer. That one main computer is master node, the computer which we are writing a script on. What is driver program? Well, driver program is nothing but the script which we write. Okay, the script which we write, the PySpark code in Python which we are actually writing. So this kind of diagram which is on your screen right now, we can say that think of the driver program as the boss of your PySpark job. It's the program you write, of course, and that defines what needs to be done. Okay, that defines what needs to be done on like the transformations and or actions and all that stuff. Well, it parses your code and then it converts it into a logical execution plan. What is a logical execution plan? Well, it doesn't execute it directly because PySpark or Spark actually uses lazy evaluation. It will not execute your plan until and unless you call an action. Well, we will learn about what is action and transformation and all that later, but for now understand that it uses lazy evaluation and it doesn't execute it directly. It waits for an action. Then we coordinate tasks across different clusters, like driver program coordinates tasks across different clusters. Okay, and yeah, so yeah, also it is one of the most important thing in the architecture, because if it is a single point of failure, if this thing fails, then your whole pipeline or system fails. Okay, so we have to be very careful while writing this code. Then there is cluster manager or the resource negotiator, we can call it. Well, it is kind of like the hotel manager. Well, it assigns rooms to guests. What are rooms? Rooms are the resources like the clusters, and guests are the PySpark jobs basically. So here you can see the receptionist is Hadoopian. Hadoopian is basically one of the cluster managers. Well, Apache Spark provides a few cluster managers, for example, standalone, like built-in basic resource manager, or Yarn. In this case, Yarn is made by Hadoop, and Mesos, it is very older, and Kubernetes is one of the new ones. Well, here you can see the Hadoop Yarn or the resource manager is looking at the jobs, which is the guest, and it is gonna give them rooms, that is resources or the clusters. Well, they can do their task, whatever the task is, and then return as the result, that is the failure or the success of the task and the output of the task. Then we have worker nodes, and as I told you, worker nodes are also called as executors. We will be looking what executors are exactly. Assume this is a gym, and these three are different people or different executors. Everyone has a certain data partition. What is data partition? It is kind of chunk of the data or chunk of the process and a job. What it does is every kind of cluster does the heavy lifting on the data partition or the task, and it provides us with the output. I think this is clear, and so we will see like what is the flow. We will recall the flow of the whole architecture is like we submit a PySpark script, the driver starts, the code, and driver asks the cluster manager for resources. Then cluster manager assigns executors the jobs, the different jobs provided by the driver. Then driver splits the data into tasks and sends to executors, and executors process the data and sends us the result back. This is how the architecture of the PySpark work. I hope you understood what we have talked about in this video. Feel free to comment and ask me any questions regarding this. And yeah, so thank you so much. The profiles, links for my GitHub, LinkedIn and Twitter will be provided in the description. Please make sure to check them out and follow me. And if you are a recruiter, you can reach me out on LinkedIn or Twitter. So thank you so much.